Hey guys, we continue doing differentiation quadratics. This is revision and I selected Edexcel exam styles questions, so that's why you can check out your skills in this area. So make sure you watch explanation for how to differentiate quadratics, why actually the turning point x coordinates can be defined as negative b over 2a. So make sure you understand that, and just general differentiation skills for their power functions like x to the power of n. That's necessary for that. Let's get started. So that's your given quadratic function with the equation 4x squared plus 6x minus 2, and you need to find the answers and give your response to the following questions. Pause the video, try to do by your own, and let's get started explanation. Alright, so you are given a function and you need to find the gradient of fx at the point a with the x coordinate x equals 2. So that's actually enough. In some questions you might be given both x and y coordinates. In this question you are given only just x coordinate, and this is not actually the problem. So the general idea, before you're looking for the gradients at the point, you need to find derivatives. So that's why you first making differentiation and looking for f prime. So simply you need to find df or dy dx. So I put df dx, okay. Actually want to write not proper, okay. So df dx, and this is f prime. So you make a differentiation and you'll get 8x, right, plus 6. Okay, that's the general idea how gradient looks like. So gradient is the function of fx. So gradient of fx is simply f prime, and that's equal to 8x plus 6. What are you going to do next? You just plug in x coordinate x equals 2. So that's why you're looking for f prime from the value x equals 2. Alright, so f prime from x equals 2 is going to be 8 times 2, 16, and plus, so I just write that quick, and plus 6 in the end, so you'll get 22. So that's the answer for the first question, A, where you have the gradient at the given point. So why it's only x, it's enough for that point. You're not supposed to have any like a, because obviously your point a is on the curve. So that's why by plugging x equals 2 into your function, you will always be able to find the coordinates. So if you plug that, let's just clarify this case. So how to find the both coordinates x and y. So f from 2, simply you plug in there and there 2. You'll get 2 squared is 4, 4 times 4 is 16. So plus 6 times 2 is 12, and minus 2. So simply it's going to be 26. So when x is 2, the result for y is going to be 26, and that's y coordinates. Okay, so that's why x equals 2 is enough. So let's go to B, the coordinates of the point on the curve fx where the gradient is negative 3. So you equate in your general function for the gradient, which is 8x plus 6. You equate to negative 3 because this is the gradient and this gradient needs to be negative 3. So that's B part, okay? So before that was A. So from there you simplify and x value from there. So you just solve this simple linear equation. It's going to be negative 9 over 8. So if you calculate just using calculator, that's going to be around negative 125. Not around, but precisely. Okay. So that's the value for x at this given point. That's x coordinate of that point. And we also need to find the y coordinates of that point. So what do you need to do? You just need simply to plug into your original equation. So let's plug that, and f from the value negative 125 will give you the following. So 4 times 125 squared. I didn't put minus because I know that this will give me the negative squared, give me positive answer. Anyway, so that's the result, and negative 3, 6, 8, 8 to 3 decimal place. So y coordinates is going to be negative 3, 6, 8, 8. Okay, so we found both coordinates for the point where the gradient is negative 3. Okay, so and finally we need to find the gradient of fx at the points where the curve meets the straight line with the equation. Okay, so you're given that equation gx equals 3x minus 2, and we'll just go move next. So here is the straight line, definitely 3x minus 2. So graphically I just depicted it already. So this is parabola, quadratic function, and this is the straight line with the equation 3x minus 2. But even not using the graph, so as you can see here, there are 2 points of intersection. And those points you need to find the gradient of fx, okay? But this is graphically. If you can use GDC, no problem, you just plug that. And instead of solving algebraically, you can use graphically. And graphically, there are 2 points. So the first x1 equals 0, because that point with the coordinate y equals negative 2 should have x coordinates equals 0. So that's on the y-axis. And here is another x2, which is, so this is the vertex. It seems to me it's negative 3. Okay, so just let's define that. So this is x vertex, negative b over 2a. So it's going to be negative 6 over 8. Okay, we'll get negative 3 over 4. So that's value for x2, negative 3 over 4. And graphically, you already got those points, okay? But I'll show you how to do it algebraically as well, okay? So how to do it algebraically? So algebraic approach. So algebraic approach. Okay, what are you gonna do? You just simply need to equate gx to fx because they have common points. So that's why you equate, and from there you're trying to solve simultaneous equations. So algebraic method works fast, pretty fast, I think. So in this case, that's pretty easy quadratic equation without free coefficients. So that's why you'll get plus 3x equals 0, because negative 2 and negative 2 will be cancelled. So you factorize and you'll get 4x plus 3 in the brackets equals to 0. So either x1 equals 0 or x2 equals negative 3 over 4, okay? Or that's negative 0.75 if you like that. And you need to find the gradient in those points, okay? Let's do that. So you know that derivative. Let's go back a little bit. So we know that derivative is 8x plus 6. So we fix that result. Sorry. F prime from x is 8x plus 6. Now you're doing the following. You simply plug the coordinates where the straight line meets your parabola. So that's why it's going to be 0. And f prime from 0 is 6. So the gradient, the first gradient is 6 at x equals 0. Okay. And the second one, f prime from negative 3 over 4. So that's the second one. And if you plug that, you'll have negative 3 times 2 plus 6 equals 0. Yeah, so in this case, f prime from the second coordinate, negative 3 over 4, will give us 0. And indeed, here, the gradient corresponds to what? It corresponds to the horizontal line, right? So this is the tangent line. So obviously the gradient should be equal to 0. So at the turning point, you will always have the gradient from negative 3 over 4 you'll have the gradient equals to 0. So that's how it works. Okay, so let's move to the next problem. Here is the function, quadratic function, and you need to show using graphs hx and its derivative h prime that the x-coordinate of the turning point is the same as the x-coordinate of the point where the graph h prime crosses the x-axis. Okay, so in other words, you need to show it graphically. So I just remind you how to sketch the graph. If you use GDC, because that's not the problem. So that's why first I'll show you how to do it without calculator, if you need to sketch without calculator. So first you find in the vertex point, okay? So vertex point, in other words, it's turn point. So if you like, you differentiate and looking for h prime. Anyway, you need that, so you'll kill two tasks at a single time, so that's why you differentiate. You'll get 2x minus 2. Okay, at the vertex point, you equate h prime from x to 0, because the gradient is 0, and that means you'll find that it's 0 at x equals 1. Okay, so that's pretty fast track. Okay, and if you plug h from 1, so you plug that x coordinate into your function, you'll get y coordinate corresponding to the vertex. Alright, so it's going to be -4, yeah, and that's why vertex coordinates are 1 and -4. Okay, second step, zeros of h from x. So you need to find zeros of the function. So you equate h from x to 0, and you solve simple quadratic equation. I like factorizing in this case, and that will give me x plus 1 times x minus 3. It's pretty easy, right? In this case, and you equate to 0, so that's why x1 equals -1 and x2 equals 3. Those are points of x-intercept, so that's x-intercept. And also the third one is y-intercept, so y-intercept. So y-intercept is simply -3. So that's c coefficient, right? So c equals -3. So we know the y-intercept. And also make sure you remember that branches up, because a coefficient, the leading coefficient is 1, it's not 0. So that's why it branches up, okay? And another way to show, we need to also plot this graph for derivative. So once we found, we need to plot h prime, okay? So I'm not gonna do that. I already pre-built that, and let's have a look. So this is hx with their equation. So this is hx, this is parabola. So you remember that the vertex points should have coordinates 1 and -4. Let's have a look before. So we found that it's right there, okay? 1 and -4, and also zeros of function -1 and 3, so that's why it's here -1 and 3, okay? And here is the function that goes that way, okay? So here is your derivative, and this is h prime from x, and the equation for that is 2x minus 2. So 2x minus 2, remember we differentiate that, and this is definitely a straight line, okay? So your question, you need to show by plotting, by sketching, using graph, okay? And its derivative, the x-coordinate of the turn point, so we found x-coordinate is 1, so in other words, x-vertex is 1, is the same as the x-coordinate of the point where the graph h prime x crosses the x-axis. Okay, so indefinitely, what we know that at a given point, at a given turning point with the x-coordinates x equals 1, the graph, or okay, the h prime from x should be 0, right? And indeed, this is exactly that point and if you equate h prime from x to 0, which is 2x minus 2 equate to 0, you'll find that x equals 1, as we did before. And graphically means that your graph of the prime of h function is going to be across the x-axis, okay? So that's an idea. On top of that, I'll give a bit more explanation there. As you can see here, from x equals 1, so for x more or equal than 1, okay, or strictly, let's say, strictly more than 1, h prime function, so h prime function is above the horizontal line. So in other words, so if I just put that, I can say that this part of the function is completely positive for x more than 1. So h prime from x is more than 0. So what it means? It means that no matter where you take in the gradient for this part of the branch, it will always positive. So h prime for that part of the for the parabola is going to be positive. So that's why you have derivative function completely above the x-axis. So what if x less than 1? So obviously h prime goes below the x-axis, and that means for any sort of that point, no matter where you take in the gradients at any point on this part of the branch, the gradient should be negative, right? If you just plot the gradient, so for example at that point, yes, it's going to be definitely negative. It will have negative slope. So that's why the part of the curve that should have the negative gradient, the corresponding the derivative of that function is going to be negative or just completely below the x-axis. Okay, so that's the idea, and also you can say a bit more words about where function is rising and falling. Okay, so that's why you can say that here is function rising. Okay, it's raise for the function h from x, and here is the fall for h from x. So it works pretty simple and pretty intuitive. So if you like that, please like this video and share with anyone who's still struggling with quadratics. But quadratics, it's pretty simple topic and you need to know well it from GCSE, from your previous study. Okay, if you're new here, don't forget to subscribe and support me, please. And see you next time.